Assalamualaikum. Good morning. Boleh dengar?
Yes, doctor.
Boleh dengar.
Lim Yun King.
Yes, doctor.
Read the question, please. 21, 22. We are referring to dash 2, 21, 22. Okay. Okay, Lim, read.
An open loop transfer function is given as gs equal 10k s plus 20 over s plus 5 s plus 30. For k equal 3, determine the following: the break frequency of the system and the sketch of the both plot for the magnitude plot. For another system with k equal 30, an open loop transfer function is given as gs equal k over s plus 8 s plus 200. The open loop both plot of the system is given in figure Q1a and figure Q1b for magnitude and phase plot respectively. From the both plot, determine the phase margin, gain margin, phase crossover frequency, and gain crossover frequency of the system. From Q1b, 1, comment on the stability of the system. From Q1b1, determine the steady state error of the system. Briefly comment on the value obtained.
Thank you. Abu Bakar, please off your mic. Thank you. So we move to the Q1E, where you are given okay, where K is given as 3. S plus 30. Okay. So system order is 3. System type is 1. Okay. So based on here, highest order is 3, and this one is S power of 1. Okay, so the break frequency, okay, if you look at here is we have to somehow normalize. Okay, so from the transfer function we have three break frequency. The T, okay, so simplify. Okay, so that's the way we simplify and identify the break frequency. Now is to sketch. Okay, so in the sketch, the magnitude dB plot. So only one. So what you should do is 20 log lah. 20 log dj omega. Okay. Everything you have to 20 log. Okay. I already teach that in the class. So now we plot the magnitude. So we have how many factors here? Gain 0 at minus 20, poles at the origin, 0 poles at minus 5, and poles at minus 30. Okay, so there is a 5 factor. So we start with the constant, yeah, 20 log 4, 27.73 decibel. Okay, there. And then you draw the second factor, which is the 20, 0 at minus 20. This one. Then we have poles at the origin. Okay, so this is K is equal to 4.
Sorry, doctor, I want to ask
Yes,
the 20 log 4, I use log base of 10. I got 12.04.
20 log 4.
Yeah, I actually got 12.04
Can
only.
you please correct other student?
Yeah, I also got 12 only.
So yeah, how much?
12.04.
Okay, sorry about that. Okay, 12 dB. And then this one is for the poles at the origin. Okay, and 5. So this is 5. And finally is 30. Okay. Okay. So I think that's enough. Okay, and then you total up everything. The 5 factors become the summations of the transfer functions. Then we move to the another one, another system where K is equal to 30. Workload is given. Okay, workload is given. Then find the gain margin, phase margin, comment the stability, and determine the steady state error. Okay, so that's cool. So GS is 30 S plus 8, S plus 200. Okay. Workload given. Okay, so we identify order, system order, go to 3, system type, go to 1. Okay, so type 1 meaning that we have to find KB. And the steady state error is 1 over KB. Okay, so you see the workload. Okay, can you see the workload, guys? Hello?
Yes.
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 So find 0 dB and the gain curve cut 0 dB here, more or less. Okay, so which is 0.02. This is omega GM, gain crossover frequency. Okay, and for the phase crossover frequency, find minus 180. Okay, it's roughly about here. Okay, so that one is 10, 20, 30, 40. Okay, omega phase margin. Okay, omega phase margin 20, 30, 40. So gain margin occurred at omega phase margin, which is here. Yeah. So then this is a 0. Okay. You can see the gain margin is, so this is the gain margin, very big. Okay. Afiq, what is the gain margin from your side? Afiq,
That.
what is the gain margin on your side?
Native 80 dB
Plus,
plus 80 dB.
okay. And phase margin? Afiq?
Oh, 40.
Huh?
40.
40 degree.
40. 40 degree.
Alah.
Tidak tak 40.
Sini bang. Bang sini. Dia berlaku dekat sini kan.
Oh,
Ni ya. Besar ni.
90.
Ha?
Negative 90.
Positif ke negatif?
Positif. Negative.
Reading dia minus 90. Minus 180 plus 90 degrees. Kan? Halo? Eh,
Tidak.
ini macam tak ready je ni. Aish, bahaya ni. So, system stable, due to positive gain margin and phase margin. Okay, okay tak? Next is the steady state error. Steady state error. Okay, steady state error ada dua cara. Two way. One is by final value theorem. Repeat.
Final value theorem.
Final value theorem.
Everybody. Final value theorem.
Final value
Final
theorem.
value theorem.
S K berapa? What is K? K is 30, eh? S M. Abu Bakar, كم هذا؟
Uh, 0.012.
0.0.
12.
Allah Rabbi. 200 or 20?
Sorry, this is 200. Sorry.
Huh?
Uh,
200, eh?
0.018. Yeah.
Huh?
Yes.
0.019, eh?
Yes.
Seriously? 53? Oh, too big. Comment? Too big. It be reduced by observation. Workload. Okay, so we have to delete this one first. Okay. Uh, Farhani.
Ya, doktor.
Nah, sebaik lagi. Berapa ni?
Uh,
0.001.
20, 26.
Huh? 26. Farhani said 26. Cuba tengok betul.
Hmm, 25.5.
1.5. 26 lah.
Hmm.
Okay. Farhani, another one here at 0.01.
6.
Okay. So this slope is equal to minus 20 dB per second. Am I right? Kan? Lee, the slope.
Yes, betul.
So you use a ruler. You use a ruler. I don't have ruler, so I use my iPad. Something like that. Okay. Cut 0 dB. Kat mana tu? dB dia tu kat mana? Zero. About here. KV-nya is 0.022. Okay. KV 0.022. Equal to
45.45.
45
45.
big. Okay. So we can compare lah 53 by formulations, 45 by observations. Okay, it's very big. Next question. Oh, so we move to the second questions. Question 2A and 2B. Nevin,
Yes, sir.
silakan.
The performance of the unity feedback control system shown in figure question 2 has been tested using frequency response technique. For design in frequency response, the concept of stability, transient response, and steady-state error are used. Briefly discuss how a closed-loop system is considered stable in frequency response. Briefly discuss how the steady-state error of a system can be improved in frequency response. The workload for GS when K equals to 150 are presented in figure question 2b and figure question 2c for magnitude and phase plot respectively. To improve the dynamic response of the system GS, the system's percentage overshoot is reduced to 50%. Utilizing the gain adjustment technique, determine the required percentage overshoot, hence the corresponding phase margin. For the obtained phase margin in question 2b, Roman 1, sketch the new gain adjusted magnitude plot for the system on figure question 2b, hence determine the new gain margin in K. For the system to be stable, determine the range of K.
Determine lah, bukan determine. Kena cakap gitu. Nevin,
Determine.
determine, bukan determine. Okay, so plot is given. This is magnitude, this is phase. Your comment? One Faris. Transfer function is not given. So what is the system type? One Faris. Tak datang. Kalau saya panggil nama, if I call your name, no response meaning you are not coming.
Ada. Type 1 tu kan.
Type 1 Astaghfirullahaladzim. Haris. Salah tu.
Type 0 tu.
Type 0, Doktor.
Type 0.
Type
Okay.
0.
Sebab initial slope ni adalah 0 dB per decade. Ni. Tadi tu type 1 minus 20 dB per decade. Dia punya initial slope. Yang ini 0 dB per decade. Okay, apa yang dia nak soalan ni? Concept of stability, transient response, steady-state error. Ini dalam nota dia. Okay. Buat ilustrasi lah. Gain margin, phase margin, positif. Macam mana ilustrasi dia? Gain margin, phase margin, negatif. Gain margin, phase margin, critical. Ada dalam YouTube yang saya bincangkan tu awak ikut situ. Sama je lebih kurang. Dia ngulang balik soalan tu. So, how to steady-state error ni can be improved. Maknanya dia punya KA, KV, KP must be small, as possible. Because kalau kita lihat 1 over kV. So kV is big, is small pula. Must be big lah, bukan small. Okay. Katalah kV 100. 1 bagi 100. 0. 0. 0.01. Okay. So the error is very small. Kalau kV-nya 1, kV 1, 1 bagi 1, 1. Kan? kV 1. Jadi 1 dengan 0.1 and 0.01 is two different thing. So you must make sure that the error constant must be as big as possible. Okay. So that we can reduce the amount of error of the system. So that is the theory question. I want to drag your attention to this question yang Nevin baca ni tadi. Okay. Can I make it bigger? Okay. Yeah. Okay. Both load is given as K. The gain is 150. Magnitude and phase to improve the dynamic response of the system. Yeah, the system percentage overshoot is reduced to 50%. What do you understand by this word? Very confusing. So no transfer function given. No. Just plot like this. And system type 1. So what to do? Lee, can you open the gate?
Yes.
How to start?
Oh.
First, find the gain margin, phase margin, omega PM, omega GM from here. Okay, so we find the gain margin plus 0. It's about here. Sepuluh, 20, 15. 15 omega GM. 15. Then omega PM. $20, $25 kan? Omega phase margin 25. Right. Quick, what is the gain margin of it?
Dia kejap.
Uh,
Ten.
15 kan? Radian per second. So it's 10 dB lah. Afiq, phase margin.
Phase margin 20. 20. 50. Doktor.
Okay, omega PM 25. Okay.
Doktor, betul.
Hmm?
Kalau kita tarik 15, so dapat
English,
satu benda.
English, English.
Oh, if we get 160,
Okay, 160 is halal.
then we can get
Minus 160 degree halal. Abu Bakar, what do you get?
Come again?
Your face margin, what do you get?
15 degree.
Same with me. Same.
Yes.
Our brothers get
So I also got 20.
you got also 20.
Yeah, face margin.
Brothers also got 20. So okay, consider halal. So for this discussion, you follow my answer. Okay?
Okay.
Your answer also acceptable. Right. Okay, this one is initial, stable, eh? Okay. Now is to find the what do you call? The phase margin is 15 degrees. Okay. Phase margin plus 15 degrees, which will give you zeta. What is the zeta value? So you have to use the graph attached at the back. Okay. This graph. Funny. 15 degrees. What is the zeta value? Clean? 0.12. Okay. And then 0.12 will give you, what is the overshoot? Khalid?
65.
65. Any other answer? I got 68%, 65% halal, 66% halal, 67% halal, 68% my answer halal. Okay, so it depends on how you read it. Okay, I hope you understand. Do you understand this one? Okay, so this one you will get 0.12. Use graph, attach. Then from here, you will get zeta 0.12. You will get overshoot 68%. This one use graph as well. Okay. But the design requirement need to reduce overshoot percentage by 10%. 10. So Khalid, the new overshoot will become
We'll go to the graph again.
we already go to the graph. We already go to the graph and we get the answer 68%.
Yes. You.
But the new requirement said
Uh-huh.
the new overshoot is reduced to 50%. So therefore, 68% divide by 2.
Two.
Correct. So this is the targeted lah.
Oh,
This is the targeted. Targeted.
Doctor,
Yeah.
the question stated that the system percentage overshoot it is reduced to 50%,
Yeah.
not by 50%.
It's reduced to
50.
50.
Like, should we divide or make it 50?
Okay, you have to understand the word. What is the word? Kelma.
To
Kalima.
50%.
Do you understand? It's reduced to
50%.
from 68% to.
50%.
Do you understand like that? Do you understand like that?
Yes.
Yes.
Student understand 68% divided by 2. Reduced to 50%. Quite confusing, am I right?
Yes.
Yes.
If divide by 2 will be reduced by 50%, then we
Yes.
will understand it's
Reduced
divide
by
by 2.
50%. This one is
Yes.
reduced to 50%. So meaning that
It
From
should be 50.
68 to 50.
Yes.
this one salah lah. Salah.
Uh,
Salah. Reduced by and reduced to.
mm,
Reduce is 50%.
percent.
So now the old one,
68.
the old one, 68.
68, yeah.
So we use this one. Okay?
Yes.
Okay, so 50%, you will get what zeta? 50
From the graph.
from the graph.
Yes.
0.22.
Here, I delete this one first. %. 0.22. Right?
Yes.
0.22. And 0.22 will give you new phase margin. How much? Check. 0.22. Got it?
21 or something. Can I see the graph again?
Mm.
The one above it. 25.
24. 25.
24, 25.
25.
Yeah.
25 degrees. New phase margin. Okay? Okay, guys? Okay? Afiq, record.
Boleh kan?
So, to achieve phase margin 25 degrees. Okay, so we have to find the phase curve reading. How much? Minus 165. Correct. Correct.
One five five.
155. 155. Okay. 155. Okay. 155. So we go to the graph 155 phase graph. 155. Where is it? 155 is 155, 155, which is here. Hello? Correct? Help me.
Yes.
So this will be your new omega GM. 10, 10, 20, I think it's 12. Okay?
Yes.
12 omega GM new. Okay? So we go up. Twelve. So this is your new omega GM. And the distance between the new omega GM is 12. Am I right? 12, huh? Okay, it's 12. Which occurred at 12 radian per second. 12, huh? So 20 log K. Sorry, this is not the game. Okay. 20 log 150. This one is from the original gain, eh? So which is equal to 100.21 decibel. Okay. So what we should do is gain adjustment.
Doctor, I got 43 decibel.
You got
43 decibel.
43 decibel. I don't understand this one.
20 log 150.
Yeah, 12 radian per second. Brother, the new omega GM that produce 25 degrees. Okay, 25 degrees, eh?
Yes.
25.
Mm-hmm.
25 degrees is 12 radian per second. So this is the omega GM. So we go up 12. We got how much? You got 0, 43. How much do you get?
You mean from graph I got like 4 dB.
4 dB. Okay, 4 dB.
Okay.
4 dB. Okay, 4 dB. All right. So the gain adjustment uh, that required to have overshoot 25%, and phase margin, how much just now? What is the phase margin just now?
25.
25. 25 degrees. Overshoot is 50%. Are you
50.
confusing? Very confusing. Very challenging. Okay. Is okay where you have to somehow I illustrate lah the graph kan. Macam ini. So this one is a K150. Okay. Or K The gain is 10021 dB. And what you have to do is the new one, you have to somehow shift down. You have to shift down. Okay, shift down. 4 decibel. Okay, shift down 4 decibel to have the new omega GM 12 radian per second. Okay, this one, omega GM is 15, the old one. Okay, so they have to shift down a little bit to achieve 12 radian per second, shift down 4 decibel to achieve this 50% and phase margin 25%. So the new gain margin now is how much? The new gain margin is about 20 decibel at omega PM 25 radian per second. Shift down 4 dB, meaning that 20 log K minus 4 dB minus 4 dB, so K equal to 0.631. K overall is 150 multiply 0.631 is 94.65. Okay. So therefore, the third one, what is the third one? Yeah. For the system to be stable, determine the gain margin. Gain margin. Okay. Gain margin 10 decibel. Okay. So you have to shift the gain curve, shift up the gain curve at 10 decibel. Okay. So 20 log K positive 10 dB. K is equal to 0.5, 3.16. Okay, so 3.16 overall, K overall, 150, 3.16, 474. So that's why range is 0, K 474, where 474 is K critical. Okay, guys, stop here. Okay, we stop here. Okay. Stop here, and then I see you again next week, Monday, face to face. I will share these discussions with you shortly. I already forward to you to YouTube videos. So use that, the videos, the first one, the second one, and the today one to revise your test two. Okay? You have any question, you can WhatsApp me. Thank you very much and have a nice holiday. Happy Eid Mubarak. Thank you.
Thank you, Doctor.
Thank you, doctor.
So, can I ask some questions regarding to assignment?
You can direct message to me.
Oh, okay. All right, sure. Thank you, doctor.
All right.